Okay, so in this video, we're going to be getting into the whole math section of Java, and in this video, we're going to particularly look at the first part of math. So, binary and unary operations. So, binary operations are operations that have two operands, one on the left-hand side and one on the right-hand side. So, binary operation will look more or less like A plus B, so we have one on the left and one on the right, or 30 divided by 6, one on the left and one on the right. All right? And now unary operations are operators that have only uni or one operand. So unary operation will look something like negative a, or in cases that we'll look at in the future, we'll see minus minus a or a plus plus, and we'll get into what those are in future lessons. Now, let's look at basic math operators in Java. There are 5 basic math operators in Java. So let's go through them. So the first one is addition. Let me just write out the numbers 2, 3, 4, 5. Now the second one is subtraction. The third one is multiplication. So usually we write multiplication by a dot or an X symbol, but in Java we use an asterisk. Then we have division, and in division we usually represent division in Java by using a // and then finally we have the fifth one, which is kind of interesting. We use modulus, which is a percent symbol. Now let's go over what all of these are. So the addition symbol simply adds the left and right operands together. So in this case, 6 plus 3 is equal to 9. And now subtraction subtracts the left operand with the right operand. So 6 minus 3 is equal to 3. And now multiplication multiplies the left and right operands together. So 6 multiplied by 3 is equal to 18. And then division divides the left and right operands. So 6 divided by 3 is equal to 2. And then finally we have modulus. So whenever we deal with modulus, we're actually trying to find the remainder. All right, so what would happen if, let's say, I used 15 divided by 6? What would be, 16 modulus 6? What would be the result of this? So let's say, how we use modulus is we simply divide the two numbers regularly as we would. So 15 divided by 6, we're going to divide it regularly. So this, the number on the left-hand side goes inside, and the number on the right side goes on the outside, and then we simply divide them together like we regularly would. So if we regularly divide this, it would be 2 minus 12 is 3. So then our remainder is 3. So 15 modulus 6 would equal 3. So that's how modulus works. We simply divide the left-hand side with the right-hand side like we regularly would in regular division, except instead of taking this number up top, we take whatever the remainder is. So what would happen if 6 modulus 3? What would be our result? Well, if we divide these two regularly, they perfectly fit into each other. So 6 divided by 3, we put 2 multiplied by 3 is 6, so we subtract 6, and it gets 0. They fit perfectly into each other, so 6 modulus 3 would equal 0. Alright, so that's how modulus and the basic math operators in Java work. Now let's look at an important concept known as truncation. So truncation is the process of converting a double value into an int value by simply dropping the decimal places that come after the whole number value. And it usually occurs when we divide two integer values together or when we cast a double into an int. Okay, so now let's look at let's look at the first scenario when two ints are divided. So let's say we have int a is equal to 5 divided by 6. Sure. Or no, 5 divided by 10. That's easier to divide. So over here we clearly see that we have two whole numbers. So two int values. These are integer values. Int values. And this total result will be stored in an int variable. So how will this all turn out? So let's say we have 5 divided by 10. So 5 divided by 10, if we do it regularly in math, it actually equals 0.5. However, it's stored in an int variable, and ints can only hold whole numbers. So we simply fix this issue by taking this decimal place and completely dropping. We don't round up, we just never round up. We just simply drop the decimal. If any case, we actually round it down. So our value for this would be 0, and that's how we use truncation when we're trying to divide an integer value with an integer value that is stored in an integer variable. All right? Now what happens when a double is casted into an int? So let's say we have double x is equal to 5 divided by 10. All right? And then we have system.out.println println. Let me just copy this before I move on. All right, so now we have system.out.println. We're going to print an x first, and then we're going to do the same thing. We're going to use system.out.println, and this time we're going to cast it to an int. We're going to say in parentheses int x. We're going to treat x as a type int. And now let's see what the result of this would be. Now, in regular math, this would turn out to be, again, 0.5. And since this is a double, it can hold decimal place values. So 0.5 would work perfectly inside of a double variable. So system.out.println x would simply print out 0.5. And the compiler is happy, and we're happy because we got the same results. So no logic errors, no compile errors, no runtime errors. It's all good to go. Now system.out.println integer x, so we're actually casting the double value x into an int value. So we're treating the double x as an int. So since x is a decimal value, 0.5, and we're treating it as an int value, well, what do we know about ints? It only holds whole numbers. And what happens when a whole number or a decimal number is put in an int? We truncate. So we simply take this 0.5, drop the 0.5, and we get 0. So what this outcome is 0. And that's how we truncate or use truncation when we cast in a double into an int. All right? Now let's look at some other examples of truncation and 5 main ones that I want to talk about. So let's use the numbers 3 and 4 for this example. All right, so let's say we have 3.0 and we divide it by 4. What's going to be the outcome of this? So here we have a double. Here we have a double divided by an int value. So whenever we have a double divided by an int, double takes precedence over the int, and we actually print out 0.75. This is because, again, we have a double divided by an int, and it will print out 0.75. Okay, that's all cool. Now what if we have 3 divided by 4.0? Now we have an int value divided by a double value. Well, much like the example above, this will work in the exact same manner. It will actually print out 0.75, assuming that is stored within a double variable. Because double, again, takes precedence over the int, and since we have a double dividing an integer value, remember how double values can also technically hold whole numbers? Well, the same thing over here. That's why 3 divided by, that's why an int or a whole number divided by a decimal number can equal a decimal number. All right? So double divided by an int equals a double. Int divided by a double also equals a double. Now what if we cast int to 3.0 and then we divide that by 4? So this is a double divided by an int. But then we have a special case because we cast it over here. So technically it's an int, it's a double casted to an int divided by an int. So since this is casted to a double, since this double is casted to an int, this is temporarily treated as an integer value. And then whenever we have an integer value divided by another integer value, it always equals an integer value. So this will be equal to 0 if we just figure out the math. Now, what if we have 3 divided by 4? Now, generally, this will be equal to 0, right? But what if we have a double on the outside? We have a double right over here. So, essentially, we have an int divided by an int. And just as the previous example, when we have an int divided by an int, that is equal to an int value. But this int value is casted to a double. So this is temporarily treated as a double. And now whenever we have a double divided by an int, that's equal to a double. And then this will equal 0.75. All right, so that's how that works. Now, what if we have this special case over here? This is a very interesting case. We have 3 divided by 4. And we cast the whole thing. We cast the whole thing to a double. This whole 3 divided by 4 is casted to the double. So now, in this case, we have an int divided by an int. And remember how in regular math, we just do everything in chunks according to where the parentheses are. So we do the things first. The things that are in parentheses, we do them first. So right, so we have an int divided by an int, so that will bring out a 0. But then we can't forget about this double. So this double, we cast the 0 to the double. So whenever we have that, that's just going to bring out 0.0, and that's how that one works.